Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here the numericals on viscosity. So this is related with chapter number 1, that is basics. So already we discussed the phenomena of viscosity. So actually viscosity is nothing but a property of fluid which determines its resistance to sharing the stresses. So also we can say that it is measured to the internal fluid frictions, and it is wholly depend on cohesion bonding and the intermolecular transfer or momentum transfer. So this is regarding the viscosity. So viscosity can express as a dynamic viscosity. So whenever we only mention the viscosity, we can call it the dynamic viscosity. And according to the Newton's law of viscosity, that nothing but tau is proportional to du by dy. And here we can take tau is equal to mu du by dy. So mu is nothing but tau upon du by dy. So mu is nothing but constant of proportionality, or you can say dynamic viscosity, or you can say viscosity. So this is the formula for finding out the viscosity. So as you know that tau is nothing but shear stress, mu is equal to dynamic viscosity, du is nothing but change in velocity. So here change in velocity means final velocity minus initial velocity. That is why it is called as change in velocity. Dy is nothing but change in distance. Means what? If it is two plates is there and the distance between these two plates is called as change in distance, that is called as dy. So you can put the value over here like this. So for purpose of shear stress, unit is Newton per meter square. So it is measured in terms of force upon area, right? So tau is equal to force upon area. That's why we can take as unit Newton per meter square. And for dynamic viscosity, already we discussed, that is Newton second per meter square. This is SI unit. The next is the du, that is change in velocity. So unit is meter per second. So here velocity is there, so that's why I can write meter per second. And for dy, that is nothing but change in distance. So in change in distance, we can take it as a meter. Okay. So then that important note over here, that is 1 Newton second per meter square is equal to 10 poise, or you can say 1 poise is limit 1 by 10 Newton second per meter, Newton second per meter square, or you can say 1 centipoise is there, then you can take 1 by 100 poise. So this is conversion rate for viscosity. So this is important formulas. Then other formula is there. So for power, so power absorbed by during the friction, you can calculate by the formula is P is equal to 2 pi nt by 60. And for this 2 pi, so pi is constant, n is nothing but the speed in rpm, then t is the torque. So n is nothing but the speed of the shaft and t is the torque. Okay, so for torque purpose, we know that torque is nothing but force into distance. So for that purpose, we can d by 2, that is diameter by 2. So we can take half of this distance. So this is why tau, that is torque, is equal to force into d by 2. So for next form, that is that shear stress. Shear stress is nothing but force upon area. Shear stress is nothing but force upon area. So force in terms of Newton, area in terms of meter square. So unit is Newton per meter square. Then next U, that U is nothing but velocity. So velocity is nothing but pi d n by 60. So pi is constant, d is diameter, and n is the rpm. So it is converted into that per second. Okay, that's why I can take divided by 60. Then for calculation purpose for du, that is change in velocity, we can take as a final velocity minus initial velocity for change in velocity. So it is important formula. So power is in terms of watt, or you can say Newton meter per second, or you can say joule per second. So this is regarding the power. For torque, torque is nothing but Newton, because force is in terms of Newton, and d by 2, d is a meter, so Newton meter. So torque is Newton meter, power is watt, tau, that is shear stress, is nothing but Newton per meter square, u is the velocity, that is meter per second. So this is the formula. Now we go for first problem. So assume that the plate, that is 0.03 mm distant from a fixed plate, moves at a 70 centimeter per second, and it requires a force of 3 Newton per meter square to maintain its speed. So calculate the fluid viscosity. So fluid viscosity. So only mention that viscosity. So you can write mu is question mark. Okay. So here that 0.03 is distance, that is dy, and 70 centimeter per second. So centimeter per second means velocity is given to you. Then 3 Newton per meter square. So Newton per meter square means force upon area, that is means shear stress, that is tau is given to you. So like this, given data is there, dy, right? Dy is point, that is change in distance 0.03 mm. So convert into meter 10 raised to minus 3. That is the force. That is force means tau. We can take as a tau 3 Newton per meter square. That is shear force is there. That's why I can shear stress force is there. That's what that why 3 Newton per meter square. Then u is nothing but we can write as a 70 centimeter per second. So this is final velocity actually. So that is conversion for 0.7 meter per second. And here the question is mu is question mark. Okay. So as we know that the formula is tau equal to mu dy by dy. So for solving the formula for solving the viscosity problems, always remember that this formula, that is tau is equal to mu dy by dy. So here dy is given to you directly, but du is unknown. But given that u, so du is nothing but change in velocity is equal to final velocity minus initial velocity. So you know that final velocity, this u is final velocity, initial velocity is called, we can take 0. Okay, like this, final velocity is minus initial velocity, u minus 0. U is 0.7, already we discussed. 0 is initial velocity, and this du, we can put du over here, dy that is 0.03, and mu we can is unknown thing, and tau is directly we can given that 3 Newton per meter square. So it is tau actually. Okay, so directly 3 Newton we can write here like this, tau mu divided dy 3 as it is, that is shear stress. Mu is unknown, du he calculated over here 0.7, and dy is point that 0.03 10 to minus 3. So you write likewise you can write here, and after that solution you get the value of 1.28 into 10 to minus 4 Newton second per meter square. So all units are in SI, that's why the dynamic viscosity is always, you remember that it is in terms of SI and it is Newton second per meter square. So this is all about the first problem. Now we move for next problem, that is two horizontal plates are given to you, that is placed in a 1.25 centimeter apart. That means two plates separated by distance 1.25, and the space between them being filled with oil. So the space between these two plates, it is filled with oil of viscosity 14 poise. Poise means it is given that mu. So this is the CGS system unit. So we convert into SI unit. So if you divide by 10, then it convert into SI unit. Okay, that is Newton second per meter square. Then calculate here shear stress. Shear stress means tau is unknown and the velocity is 2.5 meter per second. So here the velocity is given to you. So likewise distance is 1.25, right? Centimeter there we can convert for meter. Then next, that is 10 to minus 2. Okay, then viscosity, that is 40 poise, so we can divide by 10 newtons and meter square. So this is conversion of CGS to direct SI unit. Okay, for velocity of upper plate, so velocity for upper plate, that is u is equal to 2.5 meter per second. So this is upper plate velocity. Now we know the popular formula for that, shear stress is equal to mu du by dy, that is tau mu du by dy, tau mu du by dy. Now we put the value of mu, that is directly, then du that is change in velocity. Actually we want change in velocity, so formula change in velocity is equal to initial final velocity minus initial velocity. So we put the value final velocity minus initial velocity, and then du we find out. So after that we can put the du value, dy this is value, then you put the mu value, that is 14 by 10, that is 1.4 instead of that, and then find out the shear stress like this. 1.4, du is 2.5, dy is 0.125, and then formulating that calculation 280, that is 280 Newton per meter square. So this is regarding the shear stress for two horizontal plates. Then next we will discuss this example. So here the shear distribution over a plate is given by U is equal to 2 by 3 y minus y square. So this is the formula given to you. So I can write a given formula, then in which U is the velocity. So here U is the velocity, meter per second at a distance y, meter above the plate. So it can separate distance, and determine the shear stress at y equal to 0. So here we can calculate shear stress for y equal to 0 and y equal to 0.15. So we can write like this: tau at y equal to 0, tau at y equal to 0.15. And here take the dynamic viscosity of fluid. So dynamic viscosity means mu, that is 8.63 poises. So for conversion of SI unit, you can take divided by 10. So here mu is equal to 8.63, then 10 Newton second per meter square. So these are the unknowns. For first unknown is tau, that is determine the shear stress at y at 0, y at 0, then shear stress for y at 15. So y at 15, mu is constant, right? Mu is constant. What is the value of mu constant? That is 8.63 divided by 10. You can directly put over here and computing the different terms. So first of all, we know that u is equal to 2 by 3 y minus y square, but du is not directly given, that is in terms of meter per second, right? It is not given. So from this equation we calculate first du by dy. That means we can differentiate with respect to y. We can take this equation, again I repeat, we can take this equation and we can derive with dy and put the value of y equal to 0. Similarly, first you calculate du by dy at y equal to 0.15. So for the purpose we can take this equation, we can derive with the dy, then we can put the value of 0.15 from this point, and then we compute the du by dy at y15, and then put this y at 0, y at 15, and put the value of mu that is given to you, that is 8.63 divided by 10. Then you get the value of shear stress at y0 and shear stress at y equal to 15. So this is the given data and this is the questions. It is that asking question problems. So here first point, you take this equation, you can derive with du by dy. So for du by dy, 2 by 3, for dy by dy is 1, and for y square, so it becomes 2y. Okay, now we put for y at 0, y at 0, y at 0. So 2 by 3, 2 into 0, so I can put y is 0. So that's why equation becomes 2 by 3, 0.667. So unit is per second. Why it is per second? Because du means velocity, meter per second is there, and dy is meter. So meter get cancelled, only remains per second. So that's why always remember that velocity gradient unit is per second. So this is regarding the y at 0, du by dy at y at 0. Now we go for next, that is du by dy at 0.15. So same way we can take this equation, then we can differentiate with respect to dy. So d by dy 2 by 3 as it is, and y square is there, so it becomes 2y. Okay, and here we know the value is du by dy at y equal to 0.15. So I can place y equal to 0.15 over here, and then we can put the value of y is 0.15, so 0.15, and after that we will get the value is 0.667, and then the next, that is minus 0.30. Then next we have to put the value of the y point 10 and get the value 0.367 per second. So here we calculate first du by dy at y at 0, then du by dy at y 15, and then we put the value 8.63 divided by 10 into this over here, and then find out tau at 0 and tau at 0.15. So in next slide we will keep this value as it is. So du by dy, that value can keep like this, right? Now we can use the Newton's law of viscosity, that is tau is equal to mu du by dy, and that is tau is equal to mu du by dy for y at 0, 0, 0. So mu we can place 0.863, and du by dy, that is we can place 0.667 like this, and then equation final becomes 0.5756. So this is regarding the shear stress at y equal to 0. Next, then next for y equal to 0.15. So similarly we can know that tau is equal to mu du by dy. So y at 15, so y at 0.15, so we can take tau y at 0.15, then take the value of mu. So mu is for this side 0.863, and du by dy we can take 0.3667. So you can write like this, and after that solution we get the value of tau y at 15 is 0.3167 Newton per meter square. So always remember that shear stress is nothing but force upon area. So that's why Newton per meter square. Force is in terms of Newton, area is in terms of meter square. So unit is like this. So all units is in SI. That's why we can directly write as a Newton per meter square. So this is regarding that second problem. The next problem is, so this is quite different. So here we determine first torque and power. That's why I write first torque and power. Determine the torque required and power absorbed to overcome frictions. So T is question mark, P is question mark. So first of all, we read this example. A 50 mm diameter shaft. So this shaft is diameter 50 mm. We imagine this with 500 rpm, so it can rotate with 500 mm, and in 80 mm long. So in 80 mm long means length is given to you, that is capital L. So L is given to you, capital L. D is given to you, 50 mm. And speed, that is N is given, that is 500 rpm, revolution per minute. Then journal bearing is with 50 mm diameter. So capital D is for how much it is? Capital D, it is 51 mm. So I can write D 51 mm like this, and the loop that angular space between the shaft and bearing is filled with lubricating oil. So this area between this bearing, the general bearing, and your shaft is filled with the lubricating oil. So in between that we can place in the lubricating oil, which is viscosity is 1 points, and determine over here the force and torque. Sorry, torque and power. So torque and power, T and P. So first of all, we know that already we discussed that P is nothing but power is 2 pi nt divided by 60. So right here P is equal to 2 pi nt divided by 60. So for calculating purpose of power, we require torque, because N is known to you, that is speed. Only remain that T, that is torque. So how to calculate torque? Torque is equal to force into distance by 2. So that T by 2. You can write T by 2, right? But for calculation of torque, D is known to you, that is D is 15 mm, right? Convert into 0.05. But how to calculate the force? So as we know that the tau is nothing but force upon area. So I can take this reference, tau is equal to force upon area, because by calculating shear stress, because in between that shear stresses will cause, there is no other that load condition is there. So that's why tau is equal to force upon area for torque, sorry, that shear stress, that force is nothing but we can take tau into A, and then calculation of force we can put this here and find out the torque. Now fixed, the next is tau is equal to mu du by dy, correct? So that is shear stress is equal to mu du by dy. This is Newton's law of viscosity, and if you know that value, that is tau value, we get the force. Okay, so here I clearly mentioned that. Again I explain this. So for calculation of force, we can take shear stress is equal to force upon area. But if you know that area, the area is known to you, then tau is unknown, force is also unknown, correct? So for that purpose, we take tau is equal to mu du by dy. So here tau you can calculate F by A, mu is directly given to you, then du means what? Change in velocity. So you can calculate first change in velocity here, that is final velocity minus initial velocity. So here final velocity is given to you, that is how much it is, that value is conversion of from u pi d n by 60, right? So this velocity is converting from u is equal to pi d n by 60 because this is a tangential velocity. So I can calculate u is equal to pi d n by 60, right? And initial velocity can take 0. So first of all we calculate the du, then put the value dy. I have to calculate capital D. So capital D means maximum dia, so it is in between general bearing, and small d, so that is shaft dia. So capital D, small dy is equal to capital D minus small d divided by 2. So this is regarding the formula. So if you put the value dy and dy in di and dy, so final velocity is equal to what? We can compute from this u is equal to pi d by 60, right? And like this we can calculate the here the shear stress. So if you put the shear stress, we get the force, and if you get the force, then we get the torque, and torque will get the value of power. Okay, so for conversion purpose we know that this cycle. So again I explain this because it is important formula. So here we determine the power and torque. So we know that formula is power is equal to 2 pi nt divided by 60. N is the RPM, T is the torque. Is it clear? Now we require this torque. So for calculation of torque, we can calculate force into distance by 2. Is it clear? Now we calculate force. So how to calculate force? We know that relation between tau and F, that is tau is equal to force upon area. Force upon area, right? Now we move for force. So how to calculate the force? If you know the force, then and only get the value of tau. So for purpose of that, we know that the famous formula, that is shear stress, that is tau is equal to mu du by dy. That is Newton's law of viscosity. That is tau is equal to, here I clearly mentioned tau is equal to mu du by dy. Now we can put the value tau directly. Before that, we calculate how to calculate tau. Mu is known to you, that is 0.1. Du means change in velocity, and dy means change in the distance. So here change in distance, that is dy d by d by 2, that is capital D minus small d, that is divided by 2, that is called as dy. And for du we calculate change in velocity, that is du, change in velocity, that is nothing but final velocity minus initial velocity, that is du. And for the final velocity is not given, that velocity is not given directly. So here we compute for the next, that is u is equal to pi d n by 6, that is tangential velocity can calculate over here, that is pi into d into n. So this is regarding the structure. So first of all we calculate the dy. So here we mention this dy. Then next we go for the u, then you go for next du, this is du. Then you go for that Newton's law of viscosity, that is 4.1, and after that we calculate the tau is nothing but F by A, So F by A is there. This is the formula for finding out the tau. Then next, for after finding the force, we can calculate the torque, that is d by 2, and after that it will calculate the torque is there. N is unknown to you, pi is known to you, and 60. So this will give the value of power. So we can take this reference for solving purpose. So this is given data. So as you know that capital small dy is equal to, so first of all we take the example, that is, so here dy is nothing but capital D minus small capital D minus small d divided by 2. Capital D is 51 mm, so convert this meter. Small d is 50 mm, so in between you can calculate the dy, that is nothing but thickness of the film. So how it is thickness. And second is for finding of final velocity, we can calculate u is equal to pi d n by 60. So according to use we can use directly the next value. So this is regarding the next point. So here calculate d by d, that is 10 to 0.5. D is the 51 minus 50 into 10 raised to minus 3. So conversion of mm to meter. Then 2 is as it is and value is like this. So for the purpose we take the u value, that is again u is equal to pi d n by, this is calculated. Now second point is u pi d n by 60. So for pi d is pi d is known to you, that is 50 mm. Capital N means that is speed, that is 500. You can keep it as it is speed. And then we go for changing velocity like this. So u is equal to pi d n by 60, you can write like this, 1.309 meter per second. Then next we can, here du is equal to final velocity minus initial velocity. So final velocity we can take directly, that is u minus initial velocity 0. So as you know that small u is equal to 1.309 meter per second. So this is a tangential velocity. We can call it a tangential velocity, that is u is equal to pi d n by 60. Now we move for famous relation, that is tau is equal to mu du by dy. So we can put du value, we can put the dy value and mu value. So mu is 0.1 into du is 1.3, dy is 0.5 into 10 raised to minus 3. So after this we can selection of that tau is equal to 261.8 meter square. Now next formula is fourth, that is tau is equal to mu dy by dy. Sorry. So first of all we calculate the, that tau is equal to f by a. From that we calculate the f tau into a. So a means what? That um value is over all about the area, that is pi dl, because the whole thickness, or you can say whole the film thickness is contact with whole part, that is like this. So whole is contact. So instead of we can take diameter, we can take pi dl. Pi d means perimeter and length. Okay. So likewise we can take this. After that we go for torque. So that torque is nothing but force into distance by 2. So d by 2 is small distance, we can take 0.05 and f is equal to 3.35 and convert this value for Newton meter. So that is called as torque. Now we move for power, last, that is formula. So this is power absorbed by the bearing. So P is equal to 2 pi nt by 60. We can take the value T as it is, that is 0.0822, and then that is N is 500, already mentioned in the that form. So 2 pi as keep as it is divided by 60. So that equation, that is P is equal to 4.304 watt. So this is all about the problem. Now next problem we have discussed here, that is calculate the The dynamic viscosity of an oil which is used for lubrication between square plate of size 0.8 by 0.8. So this is the area of plate, that is 0.8 into 0.8, that is 0.64 meters square. For inclined plane with the inclination 30 degree as shown in figure, then weight of the square plate is about 300 Newton. So here directly mentioned 300 Newton for this weight, and it slides the inclined plane. So here it can incline ways, that is 30 degree, and for uniform velocity, so it is given that 0.3 meter per second. So here mentioned 0.3 meter per second, and thickness is overall about 1.5 mm. So here mentioned that area of plate, so area of plate 0.8 point, that is 0.64. Then angle of plane, so angle of plane is 30 degree. Then weight of the plate, so weight is downwards, so this is 300 Newton, we can take as it directly. Then velocity is nothing but 0.3 meter per second, and that separated distance by oil, that is dy, we can take is that value is, the thickness of the film is that 1.5 mm, that is 1.5 into 10 to the minus 3 meter. So this is formula for finding out the that value. So here calculate the dynamic viscosity, that mu is unknown, and dou upon du by dy we can take as it is. Okay, the next, for reference purpose, we can take like this diagram. So in component weight w, which is acts downward in the directions, that is nothing but it is parallel to the vertical, so that's why I can take w sine 30. So here we can divide this, and for 30, so here 30, and we can take this 60, so that y becomes it is 30. So here f is equal to 300 into sine 30, that is why sine 30 means half, so that becomes 150 Newton. So here we know that the oil thickness is value, so that is tau is equal to force upon area. So force is already calculated over here, you can put the 150, area is in terms of meter square, so already know that 0.8 into 0.8, that is 0.64 Newton per meter square, that is called as shear stress. Now we move for change in velocity, because we have to find out here shear stress, that value of mu. So we know that du means final velocity minus initial velocity. So here we get the value of that tau, and after that finding out mu, so only put the value 2.3434.3, then dy is 1.5 10 to the minus 3, and after that calculation of mu is equal to 1.17. So this is Newton second per meter square. So this is regarding the all the problems. So thank you. In the next lecture we will discuss the different remaining properties and different numericals.